Okay, so remember that congruent arcs are arcs in the same circle or in congruent circles that have equal measures. Now, for this definition, really what I want to focus on is the word measures. Okay, and here what I want you to think about is I want you to think length and not degree measure. And I'm going to elaborate on that in a second. All right, so let's focus our attention on the diagram. I'm going to bust out the highlighter real quick right here, and we're going to highlight two circles. Now, those two circles are congruent. All right, see, these are congruent circles. So circle R is congruent to circle Q. Okay, so circle R is congruent to circle Q. So if we look at this diagram, there are a few arcs that have the same central angle. So if we take a look, this arc right here is a 90-degree central angle. This arc here has a 90-degree central angle. Same thing with BC. So if we look at the arcs here, arc XY is congruent to arc AB. Also, arc XY is congruent to arc BC. And then also we could say that arc, which one are we missing? AB and arc BC are congruent as well. Now, if we look at the third triangle that I'm going to highlight in, did I say triangle? I meant circle. Third circle that's highlighted in blue. Even though this triangle has a central angle that is created that's 90 degrees, arc ST is not congruent to the other arcs. So arcs, I'm just going to write the other arcs. Okay, what I mean by that are XY, AB, this should be an arc notation, XY and BC as well. And the reason why is because circle P is not congruent to circle R or circle Q. So even though they all have the same central angle measure of 90 degrees and they have the same length, so TS, I should say degree measure. TS is 90 degrees, AB is 90 degrees, BC is 90 degrees, XY is 90 degrees. They're not congruent because they're not the same length. All right, so here's another theorem that's kind of helpful for us. It says in the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So here, if we know that angle 1 and angle 2, those central angles are congruent, then we know that JK is congruent to ML. And again, this is only true if we're dealing with the same circle or in congruent circles. So let's practice these ideas in the space below. All right, so the measure of arc BC, does that equal 45 degrees? Well, if you take a look at the diagram here, this appears to be a 90-degree angle. So its linear pair would also be 90 degrees. And since this arc is 45 degrees, this central angle has to be 45, which is telling us that BC is also going to have to be 45 degrees because 90 minus 45 is 45. So this would be true. Okay, part B. I'm going to erase this really quickly. It says AB is congruent to VW. So here's AB and here's VW. All right, so even though both of those arcs measure 45 degrees, their lengths are not the same because they're not created either in the same circle or in congruent circles. So this is going to be a false. Measure of angle DNC is 90 degrees. If you look, that's clearly labeled in the diagram. So that is true. Arc XY is 45. Well, let's take a look. Here's arc XY. Well, the central angle that creates XY is 90 degrees, so this is going to be false. The measure of XY is actually 90, which is the same as the measure of the central angle that creates that arc. Next, VW is congruent to XW. Well, if you remember earlier, we said that these central angles are both 45, which means that these arcs are both 45. And those arcs are in the same circle. So this one would be true. Those arcs would be congruent, satisfies the definition that we talked about earlier and also the theorem that we talked about earlier. And then the last one, arc AED, this is arc AED right here, is congruent to arc VZY. And again, they both measure 180, but they're not formed in either the same circle or congruent circles. So these would not be considered congruent. This would be false. Okay, we're going to look at a couple more examples, and then that's going to be the end of this video. I would ignore this stuff right there, and we're just going to focus on the diagram. So in the diagram, it says name one minor arc in the diagram to the left. There are a variety of different answers here. So remember, we're just looking for an arc that's formed by a central angle that is less than 180 degrees. So arc IH would be a good example. I'll give a second example as well, arc LK. And again, there are a variety of different answers that you can choose from here. Those are just two. Next says name one major arc in the diagram to the left. So here we're looking for an arc that's larger than 180 degrees. So one that I see immediately is arc I. And the other endpoint of this arc is going to be J. So in between there, we need to pick one of the points that that arc passes through. So really, you could pick H, you could pick L, you could pick K. I'm just going to pick H. So arc IHJ would work. Again, there are other examples of major arcs as well. Let me just do another one. You could do something like this. So, or arc JIH would work as well. The next one says, are there any semicircles? Explain. Well, the way that the diagram is currently labeled for us, the answer to that would be no. And the reason why is because there's no diameters drawn in the diagram. Now, if we really wanted to, we could draw a point, like say right here, connect the dots. Okay, and that's going to make a semicircle. But again, the way that the diagram is drawn for us currently, the way that it's constructed, the answer to that would be no, because there's no diameters. Okay, one last problem. We want to find the measure of angle AOC. Okay, so we're looking for this angle here. So in order to do this, really what I need to do is find the measure of this arc right there. So if we can find the degree measure of that arc, arc AC, then we're going to be able to find that interior angle measure. Now, the way that I would do this is, if you look, we have the measure of arc AB given to us as x plus 20, of AC as 3x plus 15, and then the measure of arc BC 4x plus 5. Now, one full revolution around a circle is 360 degrees. So all I'm going to do here to find measure of angle AOC is I'm going to add x plus 20 plus 3x plus 15, put grouping symbols around these, plus 4x plus 5. And I'm going to set that equal to 360, because again, that's one full revolution around the circle. And now it's just a matter of combining like terms and then solving for x. We have x, 3x, and 4x. We add those together, we get 8x. 20, 15, and 5, that is 40. And that equals 360. Subtract 40 from both sides, we get x equals 320. Divide both sides by 8, and we get x equals 40. So now that we know what x is equal to, we can go back and we can figure out the value of angle AOC by finding the measure of arc AC. So I'm going to do 3 times 40, and then add 15 to that, and that's going to give us 135. So again, I'm plugging in 40 here. So 3 times 40 plus 15 gives us the measure of angle AOC. So the measure of angle AOC is 135 degrees. All right, so as I had mentioned before, there's going to be some evidence of learning that you're going to have to submit that's posted to Google Classroom. I hope this video was helpful. Please feel free to email me or comment on Google Classroom with any questions or concerns that you have. Have a great day, and we will talk to you soon.